Very good afternoon, my dear student. In this particular lecture, we will see how to calculate sphericity of cylinder. So let's start. Problem statement is given. The problem is calculation of sphericity of a cylinder having 1 mm diameter and 3 mm length. We all know that for spherical particle, sphericity value is equal to 1, and for non-spherical particle, my sphericity value should be less than 1. And for non-spherical particle, how will you calculate sphericity? I have shown this formula. Okay. So for non-spherical particle, the sphericity is calculated by 6Vp divided by SPdP formula. Okay. So now let's focus on the solution part of the given problem. Step number 1 is what? Formula and definition. We all know that for non-spherical particle, phi s is equal to 6Vp divided by SPdP. Here we want to calculate sphericity of cylinder. Okay. So in this particular sphericity formula, that Vp stands for volume of particle, Sp stands for surface area of particle, and dP is equal to equivalent diameter of particle. So to calculate sphericity, we require three terms, right? That is volume, surface area, and the diameter. So let's calculate these three particular things: diameter, volume, and surface area. So step number 2 is surface area of cylinder, that is SP. So here I have shown one cylinder, right? Let's assume it is closed cylinder. So particular, this is what? Circle. Area of circle is equal to what? Pi r square. Okay. At the bottom of cylinder, as it is closed cylinder, again there is a circle, right? So again area of circle is pi r square, and this is what? My height. So related to height, my a cylinder area is what? 2 pi rh. 2 pi rh. Okay. Now to calculate overall surface area, I need to what? Add all these three terms, right? So it will become 2 pi r square plus 2 pi rh. Okay. 2 pi r is what? Common. Okay. It will be pi d into d by 2 plus h. Now put values of diameter and height from the problem statement. You will get your SP, that is surface area of cylinder, right? Now next, step number 3 is what? Volume of cylinder. So volume of cylinder, formula is simple, pi r square h, right? Now put r is equal to d by 2, because in problem statement we have value of diameter and not the radius, right? So better to convert radius into diameter. Okay, so put r is equal to d by 2, h as it is, put values, okay, and calculate volume. Now step number 4, equivalent diameter. So whenever you are asked to calculate equivalent diameter, always compare your sphere volume with your given particle volume. Here we have cylinder. Okay, we want to calculate sphericity of what? Cylinder. So compare sphere volume with cylinder volume. Why sphere volume? Because in sphericity we always take reference of sphere. Okay, the sphere volume in terms of diameter is what? Pi by 6 dp cube. Okay, cylindrical volume we have calculated in step number 3. So take value of cylinder volume, that is 2.35. Now you will get dp cube and dp cube to dp. Okay, so step number 4 is what? Equivalent diameter of your particle. Clear? And final step is what? To calculate sphericity. Now we have SP term, now we have VP term, now we have DP. Okay. Now we have all three unknown parts. So we can easily calculate sphericity. So put the VP, SP and DP values in sphericity formula. What is formula of sphericity? Phi s is equal to 6 VP divided by SP DP. Put all three value. 6 is fixed. Okay. It is what? Fixed value. Put all the value and you will get value of sphericity of cylinder having 1 mm diameter and 3 mm height. Make sure this value should be less than 1, because cylinder is what? Non-spherical particle. Okay, my value is my value of sphericity for sphere is equal to 1. Okay, अगर मेरा स्पेरिसिटी का वैल्यू 1 से ऊपर जाता है कोई भी नॉन स्फेरिकल पार्टिकल के लिए, तो आपको मतलब दूसरी बार चेक करना पड़ेगा और चेक कर ही लेना चाहिए, बिकॉज एवरी टाइम मतलब जब भी आपकी वैल्यू 1 से ज़्यादा आती है तो आपका आंसर रॉन्ग है, बिकॉज फॉर नॉन स्फेरिकल पार्टिकल sphericity should be less than 1, and here we get 0.78, that is what, less than 1. So my answer is what, correct. I hope this will be helpful for chemical engineers for mechanical operations subject. Thank you all.